In Chapter 5, we're going to be talking more about triangles. And Lesson 5.1, we're specifically going to focus on perpendicular and angle bisectors. These are two topics that we've talked about earlier in the year. We're just going to refresh on those and maybe add a little bit more new information. So you can see on our note sheet in the two diagrams here, both of those segments are being bisected. And we know that bisect means to be cut in half or cut into two equal parts. The definition stated above for the perpendicular bisector says that it can be a line, a segment, or a ray that is perpendicular to the given segment and passes through its length. Well, in both cases, whether the bisector is perpendicular or not, it is going to pass through the midpoint. Now, as we compare in diagram 1, I can see that this is not a perpendicular bisector. Therefore, when I look at point Q on that bisector, and I would compare A to Q and B to Q, that A to Q would be a greater distance than B to Q, or a greater length. However, looking at diagram 2, my point S on the perpendicular bisector, when I compare J to S to K to S, J to S and K to S, that would be the same length, right? This segment here and this segment here would be equal. And even if I extended this out and I put on here S prime, and I compare J to S prime and K to S prime, that my J to S prime would still be the same length as K to S prime. And as we had talked before when we did our constructions then, meaning that any point on this line would be the same distance from J as it is from K. So any point on that line would satisfy kind of those conditions being the same distance from the endpoints. That is actually called a locus. A locus is a set of points that satisfies a particular condition. Each of those points is equidistant to the endpoints. Equidistant meaning it is equal distance. And that is exactly what the perpendicular bisector theorem says. It says that if a point is on the perpendicular bisector of a segment, it is equidistant from the endpoints. That's an important note there. So I can see that I have a perpendicular bisector, which means that this segment and this segment must be the same, or AC must equal BC. The converse of that is also true. It reads that if a point is equidistant from the endpoints, then it is on the perpendicular bisector. So if I know that this is AE is the same as BE, then I must know that AD would equal BD. This is also bisecting, and D would be my midpoint. So they're going to ask us today to find some of our measures, our segment lengths, or our angle measures. If you look at example A, they're asking us to think about the length of WY. Well, I can see here that I have WX as 9 and ZX as 9. If that is equidistant, this must be a perpendicular bisector, meaning that Y must be a midpoint, or WY must be a length of 3. Looking at number 2, finding RT here, well, I can see that S is a midpoint and it's perpendicular. So my segment for RS must be a perpendicular bisector. Therefore, 2x plus 3 and 4x minus 7 must be equal. So I'm going to take 2x plus 3 and set it equal to 4x minus 7 and solve. I'll bring my x's to one side, my numbers to the other. And it looks like x is going to come out as 5. Now this isn't my final answer because remember they wanted RT. So I'm going to have to take that and plug that in. 4 times 5 minus 7, and we would find that RT is 13. Taking a look at example B. Example B, they're wanting us to write an equation in point-slope form for the perpendicular bisector of the segment with the given endpoints. This is kind of a tough question because there's quite a few steps here. But writing an equation in point-slope form, we might first need to remind ourselves, what is point-slope form? Well, point-slope form looks like so. Y minus y1 equals m times the quantity x minus x1. And just to kind of give us a visual, let's just go ahead and roughly plot points A and B. So I'm going to come over here and I'm just going to sketch my coordinate plane, -1, 6, and 3, 4. This is just a rough estimate there of my segment AB, but I want the equation of the perpendicular bisector. So if you think about it, I don't want my equation for line AB. I actually want my equation for the perpendicular bisector, which would be this blue line right there. Now, we talked about writing our equations in chapter 3, and we said the very first thing we would do is think about slope. Well, because we have endpoints for A and B, let's go ahead and find the slope of that pink segment. Now our slope formula, y2 minus y1 over x2 minus x1. I'm going to go ahead and plug in my numbers. My slope comes out to -1/2. That means that the slope of this pink line is -1/2. We want the equation of my blue line because these lines are perpendicular. Remember, this slope would be the opposite reciprocal, positive 2 over 1, or simply 2. So the slope that I'm going to be using is m equals 2. Now I also need a point that it passes through. I will show you that my blue line does not pass through point A. It does not pass through point B, so it cannot pick either of these coordinates. However, it does pass through this point right here, and I would be able to calculate the coordinates of that point, right? My bisector passes through the midpoint. So let's take my segment AB and let's find its midpoint. Now, midpoint is the middle, so that's when we're going to go ahead and average our x's and average our y's, and we're finding a coordinate point. So this is the formula that we're going to use. I'm going to plug in my numbers. You'll notice that the midpoint is adding. Let's see. 2 over 2. 10 over 2. So this looks like a midpoint of 1, 5. So that's actually the point that this line passes through. That's the information I'm going to use when I plug it in to my point slope formula. So now I just have to take these numbers and substitute them in. Point slope formula, the equation for my blue line would look as so. Y minus 5 equal to 2 times the quantity, x minus 1. And that would be my final answer. Looking down below, we're going to talk a little bit about angle bisectors. Now, we have talked about those in chapter 1 and continuing so throughout. But we know that an angle bisector is a ray that divides an angle into 2 congruent angles. And that's what my picture is trying to show here with these little arcs, that these are congruent angles. We know that if this was 25 degrees, this one would also be 25 degrees. Now I just want to point out though that that doesn't tell me anything about my side lengths. So that, well, I cannot mark those congruent. Those still could be different lengths. However, noticing my point D on my angle bisector here, I know that's running right down the middle. So that would actually be the same distance to my sides of my angle. So if you take a look at the angle bisector theorem, it actually reads as so. If a point is on the bisector of an angle, it is equidistant from the sides of my angle. Now the shortest distance between a point and a straight line, or between a point and a line, is a straight line, which is why they have those 90-degree markings. But if this is marked as my angle bisector, I know that this segment here and this segment here would have to be equal. And so I know if this had a length of 5 units, this would also have a length of 5 units. The converse of that is also true. If a point on the interior of my angle is equidistant, so if I know that these are the same distance, then there must be an angle bisector. Let's take a look at example C. Example C tells me that the measure of angle BAC is 38 degrees, BC equals 5, and DC equals 5. Now in a question like this, I'm going to label with pencil because we're going to end up changing these numbers as we go through. Angle BAC is 38 degrees. Hopefully you can see this. And BC is 5 and DC is 5. So this is telling me those segments there. Now it wants the measure of angle DAC right in here. Well, because these are equidistant to the sides, this must be an angle bisector. And so would you agree angle DAC would have to be 38 degrees. Now when I go to question 2, this is kind of a reset. So then we're going to erase and start over. Question 2 tells me that angle BAC is 40 degrees and the measure of angle DAC is 40 degrees. 40 degrees here, 40 degrees here. DC measures 10. Find the measure of BC. Well, again, it's kind of the opposite. If these are both 40 degrees, my angle bisector, point C must be equidistant, and so BC would have to be 10 units. And the last one for example C, it states that if AC bisects angle DAB, BC is 4x plus 8, and DC is 9x minus 7. Well, if this is my angle bisector here, I know that these two segments are going to have to be equal. And so that's how I'm going to set up my equation. 4x plus 8 must equal the 9x minus 7, and then we would solve. We're going to get our x's on one side, our numbers on the other, divide both sides by 5, and we would find out that x is 3. Now again, they don't want to know what the value for x is, they want to know the value for BC. We would plug that in, 4 times 3 plus 8, and we would find out that BC is 20. One more. Example D. Find the measure of angle MKL. So angle MKL, right in here. Well, here my tick marks tell me M is equidistant to the sides of my angle, which must mean we have an angle bisector. These two are pointing to my two smaller angles, and so we're going to say that 2A plus 26 must be equal to 3A plus 20. A is on one side, numbers on the other. Looks like A is 6, but again, we need to take that and plug that in. 2 times 6 plus 26. Our angle measure must be 38 degrees. Okay, if you have further questions on this, you can see other online videos provided by our textbook, or please stop in and visit with me.